All right, today we're headed to Mars. Our robotic explorers up there, they're getting a seriously revolutionary upgrade. We're talking about a massive boost in speed and intelligence, and the craziest part? It's all happening without adding a single new piece of hardware. So, how is that even possible? Let's get into it. Okay, check out this number. 97.97 meters per hour. That is the average speed Perseverance, our most advanced rover, drives on its own. For a multi-billion-dollar machine, that is shockingly slow. I mean, to put that in perspective, your average tortoise moves about 3 times faster. No joke. And that really brings us to the core question here, doesn't it? Why are these incredible cutting-edge machines so painstakingly slow? Well, the answer really pulls back the curtain on just how hard it is to explore another planet. The truth is, you can think of our rovers as, well, handcuffed explorers. They've got all this amazing potential, but they're held back by some really fundamental limits that force them to be incredibly, almost painfully cautious. Here are the 2 biggest handcuffs. First, the communication lag. It can take anywhere from 4 to 24 minutes for a signal to get from Earth to Mars. One way. Just imagine trying to drive your car, but every time you turn the wheel, you have to wait 24 minutes to see what happens. Yeah. Then there's the rover's own vision. Its cameras can only spot hazards about 3 to 5 meters ahead. It's basically driving in a constant, thick fog. So when you put that lag and that limited vision together, you're forced into this stop-and-go driving style. The rover inches forward, stops, scans everything, radios home, waits for instructions, and then inches forward again. Mission planners back on Earth have to map out every single move, and their #1 priority is safety, which means sometimes they have to skip potentially amazing science just because it's a little off the pre-approved super safe path. But what if you could just take those handcuffs off? That's where this really brilliant new idea comes into play. A way to completely supercharge the rovers using nothing more than a software update. And I mean that literally. No new wheels, no new cameras, no souped-up computers. This entire game-changing transformation happens by beaming a software patch across millions of miles of space to the exact same hardware that's already sitting on Mars right now. It's all about making the rover smarter, not just stronger. Okay, so step 1 is all about unlocking the hidden potential of the sensors the rover already has. We're basically giving it a set of super senses, letting it see the Martian world in a completely new way. So take this synthetic aperture radar, or SAR. The new software repurposes this thing for navigation, giving the rover what is essentially X-ray vision. It can map the terrain in 3D, and this is the crucial part, it can see several meters underground. It can spot buried rocks or patches of soft sand long before its wheels get anywhere near them. Then you've got the Inertial Measurement Unit, the IMU. The best way to think about this is like the rover's inner ear. The software now uses its data to give the rover a sense of perfect balance. It knows its exact position and can instantly adjust if a wheel slips or it hits a bump, which means it can now tackle much rougher ground with way more confidence. The software also taps into the angle of attack sensors. These are usually for aerospace stuff, but now they let the rover feel the air. By sensing tiny changes in airflow and atmospheric pressure, it can get an early heads up on things like developing dust storms, making the whole mission a lot safer. So, the rover now has these incredible super senses. But what does it do with all that new information? Well, the next part of the upgrade gives it a much faster, much smarter brain so it can start making its own decisions. See, instead of a one-size-fits-all approach, the software gives the rover a whole new strategic playbook. It can choose between 3 different advanced pathfinding algorithms. If the terrain ahead looks pretty clear, it'll use A-star to calculate the absolute most efficient path. If something unexpected pops up, it switches to D-star to replan on the fly. And if it's heading into a totally unknown area, it uses RRT-star to quickly find a path that's guaranteed to be safe. It can now pick the perfect tool for any job. And now, for the final piece of the puzzle, and this is maybe the most ambitious part, completely breaking the rover's dependence on Earth for communication. It's time to actually build a network on Mars itself. So right now, we use what's called a star network. Every rover has to talk directly to an orbiter or all the way back to Earth. It's slow, and it creates a massive single point of failure. The new system creates a mesh network. Now, the rovers can talk to each other, hopping data from one to the next. If one rover goes offline, the network just finds another route. It's resilient and it's self-healing. And the tech that makes this whole thing work is called LoRaWAN. It's a low-power, long-range communication standard that is just perfect for the Martian environment. It lets the rovers create their own little Mars internet, sharing data and coordinating their actions without having to phone home for every single little thing. So, you give the rover supersenses, you give it a smarter brain, and you give it a way to talk to its friends. What does all that actually add up to? Well, the results are pointing to nothing less than a brand new age of exploration. And the results are just staggering. We're not talking about a little 10 or 20% improvement here. We're talking about the rovers being able to move anywhere from 3 to 27 times faster. The tortoise has officially become a hare. And here's exactly why that speed is now possible. Remember that old 3 to 5 meter detection range? Well, with all these new senses working together, the rover can now spot hazards from 50 to 100 meters away. It can finally see far enough down the road to safely put its foot on the gas. And what does this all mean for the rover's workday? It means a huge leap in autonomy. The rover can now operate on its own 95% of the time. Think about that. For nearly its entire day, it's no longer sitting around waiting for commands from Earth. It can just keep going, exploring, discovering, doing science. This all comes together in the metric that really matters: distance. Where a rover used to cover, maybe on a really good day, 100 to 200 meters, it now has the potential to travel up to a full kilometer every single day. That just completely changes the scale of science we can do on Mars. Which leaves us with one last really exciting thought. For decades, our robots have been exploring Mars with their hands tied behind their backs. This software revolution is finally setting them free. So the real question is, now that they can finally truly explore, what incredible secrets are they going to find?